So we can do a one-dimensional example of this. If we could ask the question, if I take a ball and I throw it up in the air, how fast is it going after 1 second? Okay, we can start with our strategy. And we want to find out if we take a ball thrown upwards, and we have to give it a velocity, so we'll say velocity of 1 meter per second. Where is it after 1 second? Okay, so we have this in one dimension. The model we're going to use is going to be our linear motion. Linear motion in one dimension. And we're going to draw a picture of this. So I have this ball, I throw it up. 1 meter per second is the velocity. We know that there is an acceleration due to gravity that's acting in the opposite direction. So we'll call that minus 9.8 meters per second squared. And the question is, you know, what don't we know? We don't know its position, its final position as a function of time. So we want to find xf. This is what we don't know. What we do know is we know the initial position, we know the initial velocity, and we know the acceleration due to gravity. So the initial position, I get to choose what I want this to be. So I'm just going to call that x equals 0. Okay, my initial velocity we decided was 1 meter per second, and my initial acceleration is 9.8 meters per second squared. So I can go ahead, I think that's, we should write down the equation here that we're going to use, is that the final position is equal to the initial position plus the initial velocity times time plus 1/2 at squared. And the only thing we have to worry about here is that when we're acting with gravity, the acceleration is in the opposite direction. Since this is an equation where we have to take into account direction, I'm going to change that to minus g. Okay, so we have this minus sign comes in because we're slowing down instead of accelerating, or instead of speeding up. Okay, so I have all my knowns, I have my unknowns, everything's good. So now we can do my solution. And my solution is, I'm going to go ahead, I know what the velocity is, I know what the time is, I know what the initial position is, so I'm just going to say my final position is equal to 0 plus 1 times 1, and those units work out to be 1 meter, because I have meters per second times second, and then I have minus 1/2 9.8 meters per second squared times 1 second squared. So those units cancel, those cancel, units look good, and I wind up with 1 minus half of 9.8 is what, 4.9. So that's going to be minus 3.9 meters. Okay, so that's interesting. We got a negative sign, so why is that? Well, the reason for that is let's go ahead and draw a graph here, is I had a ball, I threw it up, and because it wasn't going fast enough to counteract the acceleration due to gravity, it turned back around and went down below the place where I threw it up by minus 3 meters. So then I do my significance, negative, because it fell back down.